Welcome back, students. Last page, page 8 of our chapter 3 review packet. So we're going to try to, on these, we're going to graph the pre-image ABC and the image DEF. We're going to figure out what line it reflected over, and when we do that, it's going to be a little bit challenging because the lines are not our typical lines. It's not a vertical line, it's not a horizontal line. It's a line that's got both X and Y in it, so it's got a slant to it, and it's not our typical Y equals X or Y equals negative X. It's going to be a little bit of a challenge. So I'll go ahead and graph triangle ABC. And triangle DEF, the image. All right, now what you're seeing right now is Y equals X is not going to cut it. Y equals negative X is obviously no chance here. So what I have to do is I have to map A to D through a line reflection. The way to do that is to understand that a line reflection is the perpendicular bisector for each vertex, pre-image to image. So what I'm going to do is I'm going to count A to D is right 6 down 2. I'm going to find the midpoint, that's the bisector part. So that's going to be here at -1, 0. And then I'm going to find the perpendicular line through the point -1, 0. So there's the midpoint at -1, 0. I'll call it M, capital M. Now I'm going to work the slope of AD, which is -2/6. So it's right. The rise is 2. The run is 6, but it's going, as we move left to right, it's going down. So that's where the negative comes from. I'll reduce it. I'll factor out a 2 to get it to -1/3. And a perpendicular, that upside down T is perpendicular. So I'm going to create the slopes that are negative reciprocals. So it's going to be 3/1, positive, because we want to change the sign. So basically we should say change the sign and flip the fraction. But we have to use the term negative reciprocal. So now the equation, I use point slope form, but it's much probably easier for students coming from algebra to use y equals mx plus b. So if we go from this point up 3/1, we're going to run into the y-intercept of 3. So yeah, so I'm starting to graph that. And hopefully, as you see it now, you imagine folding it over using that line. A would go to D, B would go to E, C would go to F. Okay, so now for 20, I have to explain my reasoning. So the line of reflection is perpendicular bisector for any image, pre-image to image pair. So perpendicular slopes are negative reciprocal. Bisector, you can find the midpoint. I'm going to repeat the same process on the second one. It's going to be the exact same concept. Just more practice at basically writing the equation for a perpendicular bisector. Now, I picked A to D because it was the smallest segment. I could have picked any pair, C to F, B to E, doesn't matter. So again, I'm connecting A to D because it appears to be the closest. From A to D, we have a rise of 4, a run of 2, and as we move left to right, it's actually going to go D to A if we follow the slope here. It's a positive slope. The midpoint is going to be at -1, 2, 3, -4, 0. And the slope is 2. The negative reciprocal of that is -1/2. So again, I'm going to apply slopes that are, the point slope form. Most of you are going to, use slope intercept form because it will work. Down 1, right 2 will take me to -2 on the y-axis. So I'm showing that right there. Sorry, a little hiccup. And back to it, right there. That's the line. Y equals -1/2 x minus 2. Again, I'm explaining just slightly different so it can show you some options. So the equation for the perpendicular bisector of AD. AD is a pair of corresponding points. on the pre-image to image segment. That's it. It's the end of our review packet for Chapter 3.